Hello everyone. So now we're going to continue with use substitution. Okay, and so based on what we did today, you would probably say that doing this first problem we would let the 4x minus 1 be u, right? So u is equal to 4x minus 1, and then we take the derivative of both sides with respect to x, and we get that du is going to be equal to 4 dx. Okay. Now, the only issue is that we're missing this 4, right? Okay, because if I plug in u for what's highlighted in yellow, I don't quite have 4 dx. All I have right now is dx. So what we're going to do is we're going to do this algebra trick, right, in math. If I multiply by 1, that's not changing the expression, right? But you might be like, well, how is that going to actually help us? So the idea is I'm going to force a 4 to appear, okay, by multiplying by both 1/4 and 4. Okay. So what I'm going to do is I'm going to say, all right, well, this is the same as 1/4 times 4 dx. Okay, because if I simplified this right here, this would just be 1, right? 1/4 times 4 is just 1. But now the reason why I did that is I can see now that this 4 dx, that's du, so I can plug it in. And then right here, this is u. Okay. So this is going to become the integral of u to the 7th times 1/4 du. Okay, and then this looks a little weird, so it might be a little bit easier if I just rewrite this as 1/4 u to the 7th du. And so now I can find the antiderivative and then plug back in the x for u, right? So I'm going to have that this is 1/4 times u to the 8th over 8 plus c. So this is the same thing as u to the 8th over 32 plus c. And plugging back in, I get that this is 4x minus 1 to the 8th over 32 plus c. Okay. So yeah, so that's the idea that I need to force a 4 to appear by multiplying essentially the expression by 1. So I'm not changing the expression. Okay. So force a 4 to appear. Oops. By multiplying by 1/4 times 4. Okay, so that's essentially what we did there. Alright, so I would now go to video 2 where I'm now going to explain how to do the second problem.